All right. What are you doing with that first problem on our practice quiz?
Foiling.
Distributing and foiling and just kind of generally cleaning it up. It's quite a mess, isn't it? But if we take it one step at a time, I am completely confident that we can manage it. All right. So, did you distribute over here? Now, be careful. When you distribute over here, that negative goes all the way through. So you're gonna have negative 4x squared, negative 12x, positive 8. It's really easy to mess that up, so go slowly. All right, now foiling first, outside, inside, last. All right, now what? Combine like terms, and there's a lot going on both sides, so I think I'll combine on each side first. So this is a 1x squared minus a 4x squared, so negative 3x squared minus 12x plus 8. And then over here, negative x squared, when I add these two together, you with me? And a negative x and a negative 12. Now what?
Combine on both sides.
Now we probably want to move everything and get it set equal to 0. Now, does it matter which direction I move it? Nope. I think I'm going to move everything that way because I have a thing, a personal issue, about having my x squared be positive. So if I move the 3x, if I add 3x squared over here, that'll be positive. So then I'm going to add the 12x over. And I'm going to subtract the 8 over. So simply took all this stuff on the left and moved it over to the right. Does that look okay? Now what? Now I can use the quadratic formula, and you're thinking to yourself, oh my gosh, Mrs. Ford, you made up this problem. I can tell because the numbers are yucky. We have a calculator to help us with the arithmetic if we need it. So x equals negative b plus or minus the square root of, anybody know 11 squared?
121.
121 minus 4 times a times c all over 2a. So now I can use a calculator if I need to. I think, is that going to be 281?
Yeah.
I don't think 281 breaks down. Certainly not by 2 or 3 or 5 or 7, so I don't think it breaks down. I think we're done. That's it. So, obviously the quiz problem you have is going to be different than this one. But what's going to be your strategy? No matter what it looks like to start, what are you going to do? You're going to start by, if there's any distributing and foiling to do, you're going to do that first. You're going to collect all the like terms on each side, and then move one side over, so you have 0. And then at that point, it's a quadratic formula, or maybe it will factor, or you can complete the square, whatever you want to do. All right, got it? Okay. And then number 2, what is the domain? Now Now, in order to do this, you're gonna have to know the two rules. There are two rules that we talked about yesterday. Who remembers the two rules for domain, for finding domain? All right, stop right there. I'm gonna write that down, remind everybody. The denominator cannot equal 0. So if your problem has a denominator, whatever it is, cannot equal 0. Okay? What's the other rule? The radicand, that is the number under the radical, well, whatever is under the radical, has to be greater than or equal to 0. Those are your two rules. All right. So, using those two rules, can we find the domain of these problems? I think we probably can. Which rule applies?
It has to be greater than or equal to 0.
Radical, right? Got a radical right there. So whatever's under it, 4 plus x, has to be greater than or equal to 0. So we solve that. Subtract 4. There it is. That's the answer to the question. Done. Straight from the rule book. Okay, what about this one? Wait a minute. Jude?
You should take the square of the numbers.
Okay, now wait a second. Just keep in mind, we're following our rules. This is a domain question. So what do our rules say? If you have a radical, wait a minute, do I have a radical? No. If you have a fraction, wait a minute, do I have a fraction? So no radical, no denominator means no issue, and the domain is everything. There's nothing to solve, there's nothing to eliminate, nothing to cross out. It's all real numbers. No denominator, no radical, none. Now, what about this one? This one has what? A denominator. We know the rule says the denominator cannot equal 0. So we solve it. So 5x cannot be 3 and x cannot be 3/5. That is it. All right, and then what about the second one, or the last one there?
Denominator and radical.
It has both. So we had one of these yesterday. No big deal, it just means you're gonna have 2 parts to your answer. So the denominator part says 2x minus 4 cannot be 0. So add 4, divide by 2, x can't be 2. That's part of my answer. That's the denominator part. But as you said, there's also a radical. Whatever is under the radical has to be bigger than or equal to 0. So x has to be bigger than or equal to -1. So in the answer blank goes that and that. Because since the problem had both issues, these are the issues. Radicals and fractions are issues with domain. This one had both, so therefore it had 2 kinds of restrictions here. Okay? So, what do we need to know when we sit down and take this quiz tomorrow? Need to know your rules. The denominator cannot be 0. Whatever's under the radical is greater than or equal to 0. Right? If we know that, this should be easy enough to do. Okay? Alright, we'll put that aside then. That's tomorrow. Right? We have class tomorrow?
Yeah.
So that's tomorrow. And then now we're going to continue on with our note taking. Does anybody happen to remember, or maybe you can look at your notes, what were we just starting yesterday when we stopped? What were we just starting to do? Vertical asymptotes. And do you recall that vertical asymptotes are tied directly to domain? Whatever x cannot be is going to be your vertical asymptote. Okay, so we have several of these. All right, so this is 3C. That's where we left off, 3C. And I want to just back up 1 second. What if I said to you, find the domain, like we did on our quiz? Find the domain. Does this problem have a radical in it? No, so we worry about that. But it does have a denominator, right? And I know that the denominator cannot be 0. Right? So I can actually factor this one. Do you remember a couple days ago I said something to you about the difference of squares happens a lot. We need to be comfortable with it. This is the difference of squares. I'm looking over here. I see another one up here. They're all over the place. So you need to be able to factor the difference of squares. Since that's a 4, it's going to be x plus 2, x minus 2. If it were a 9, it'd be x plus 3, x minus 3. Now, since this is my denominator and it can't be 0, would you agree that x can't be negative 2 and x can't be positive 2?
Yeah.
Guess what? Those are your vertical asymptotes. Because when you say cannot be, does not equal, cannot be, that's a vertical asymptote. Vertical asymptotes are cannot be's. So I'm going to have a vertical asymptote where x is negative 2. So a nice little dashed line. Label it x equals negative 2. And then a nice little dashed line. Label it x equals 2. Okay? Easy enough, right? Okay, what do you think we ought to do with this guy? Yeah, where do my eyeballs look, by the way? Bottom, right? Denominator? Isn't that where I need to look? So I know that my denominator cannot be 0. Does that by any chance factor?
Yes.
How does it factor?
X minus 5, x plus
Minus 5 plus 1? So that means that x can't be 5 and x can't be negative 1. Are you okay with that? Which means when I draw my vertical asymptotes, I will draw them where? 1, 2, 3, 4, 5, and negative 1. Now eventually, we're gonna sketch this thing, you're gonna fill the rest of the picture in, but right now, we're just putting in the asymptotes. Okay, now we're gonna hit the big time. This is big time here. Does that denominator factor?
Yes.
It's kind of the same as that one, but not quite. The denominator is
Plus 5 minus 2.
+5 - 1. Now this is where things are starting to get a little more interesting. I need to look at the numerator too, because something's gonna happen here. How does the numerator factor? It's the difference of squares, x plus 1 minus 1. Now what do you notice? This has not happened before in our problems. Gio? Giovanni?
Cancel out the X1.
We have a cancellation. Now, when you cancel that out, now your problem says just y equals x plus 1 over x plus 5. That's all that's left. Would you agree with me? So now, I only have 1 cannot be. What's my 1 cannot be? X cannot be -5? Because that's the only thing left in the denominator, right? So is everybody with me so far? Because now I'm going to throw in a new thing. So I need you to make sure, I need everybody to be okay with where I'm at right now. I have a vertical asymptote at -5. X equals -5. That's how we label it, just like that. Is everybody okay with that? However, in the beginning, if I hadn't paid attention to the canceling, there would have been another cannot be. Would you agree with that? And where would that one be? At 1? So in the original problem, 1 was potentially a cannot be. Now luckily I could cancel it out. When you cancel it out, you get what's called a removable discontinuity, which is a hole in the picture. Now, the word removable hopefully makes sense to you, because what happened to this x minus 1? Wasn't it removed from the problem? So, in the beginning, it looked like I was gonna have another cannot be, but we removed it from the problem. That means it won't be an asymptote, but it will be a hole. So instead of having an asymptote where x is 1, I'm going to have a hole in my picture, an open dot. Okay? So, how do I know I'm gonna have a hole? Whenever I cancel. How do I know where the hole will be? It will be at whatever you canceled out. So, there should have been an asymptote at 1, x equals 1, but I canceled it out, so now there's going to be a hole where x is 1. Now, any idea how I will find the y coordinate? Giovanni? Exactly. And when I plug it in, I gotta plug it in my new problem. So I plug it in my new problem. So if I put in 1, I have 1 plus 1 over 1 plus 5. Put in 1, which is 2 over 6 or 1/3. So in my picture, at the point 1, 1/3, so over 1 up 1/3, I have an open circle. Not an asymptote, just an open circle called a hole. A removable discontinuity. Why have none of my problems up to this point had a hole in them? Why is this the first time I'm talking about that?
They weren't X squared.
They weren't canceled. Couldn't cancel anything. Look at them. Nothing canceled. The only way you can have a hole is if you can remove it, if you can cancel it out. Welcome to pre-calculus, folks. That's the real deal. All right, you ready for the next one? All right, let's take a look at letter F. What do you think I should do first with this problem? So think about the last one we did. What did I do first over there? How'd we start this? What did we do?
Denominator.
Well, we factored the denominator, and then we also factored the numerator on the off chance that something might cancel, right? So, let's see. How would the denominator factor? X plus 4, x minus 4. That's our difference of squares. How will the numerator factor? Can you do that one? X plus 5, x plus 4. Everybody okay with that? What do you notice? These are gonna cancel. So now our problem is just x plus 5 over x minus 4. This is our new problem. Now, two things are gonna have to be put in my picture. This will still have a vertical asymptote. Look at the new problem. Where will the vertical asymptote be? At 4? Because x minus 4 cannot be 0, so won't your asymptote be at 4? So I'm going to have a vertical asymptote at x equals 4. Remember, vertical asymptotes come from the cannot be's. The cannot be's come from the denominator cannot be 0. But what about this? If I look at my original factoring, there should have been 2 cannot be's. 1 at 4 and 1 at -4. But I canceled out the -4 one, so it does not show up as an asymptote, it shows up as a hole. Look at the factor I canceled out. If I solve this factor, don't I get -4? That's where this is coming from. Now, I need to plot this point, so I need a y. Where am I going to get my y from? I'm going to plug it in right here. Plug it in right here. So I'll have -4 plus 5 over -4 minus 4. So -4 plus 5 is 1, and -4 minus 4 is -8. So -1/8. So I'm going to come over here to my picture, and I'm going to plot the point left 4, down 1/8, and there's the hole in my graph. Now we will complete the rest of the graph at a later time, but right now we're doing vertical asymptotes and holes. In a few minutes, we'll do horizontal asymptotes. All right, but there's one more. Oh my golly. Oh man. This one looks crazy. Okay, this one's gonna take up a lot of space. So does anybody still have a question about this? Because I'm gonna erase this here in a second. Are we okay with this? Okay, look at this this next one. Oh my goodness. Alright, so what's your thought? You have a thought on how to even begin this?
Factor the denominator by grouping.
Factor the denominator by grouping. Oh my goodness, think about the test we just took. Didn't we need to factor by grouping when we had this many terms down there? So, who remembers what factoring by grouping means? Put it my denominator, Gene.
Factor like each group, so like the first one.
So, what can I pull out of those guys?
X squared.
X squared. And I'll be left with x minus 4. Oh, this is unusual. What can I pull out of the last two? Negative 1. The minus sign, I'll pull out the minus sign. And if I take out a minus, I'll be left with x minus 4. That's really good news. And this is still my denominator, I haven't done the numerator yet. In fact, isn't this my denominator then? Here's my x minus 4, and then x squared minus 1 is left. And what about x squared minus 1? Difference of squares. X plus 1, x minus 1. Guys, I told you, you gotta know that. You gotta be able to factor the difference of squares. Since that's a 1, it'll be x plus 1, x minus 1. If it were 25, it'd be x minus 5, x plus 5. Okay, so all that work so far is just to get my denominator, which at this moment looks like there are going to be 3 cannot be's. But I need to check my numerator. Does that guy factor?
Yes.
Yes.
How does he factor?
X minus 6 plus 1.
X minus 6, x plus 1. The combination of 5 and 6 often trick us. I think that's right. So double check what you put down. If you put something different, boil it out and make sure. I think that is the correct factoring there. Okay, so this is our problem. What do you notice about your problem now that it is factored? We can cancel one thing. We can cancel these guys. What does that mean in terms of my picture? If I can cancel something out, that means I will have a whole. Eli, please look up. This is really cool stuff. Where will the whole be? It's going to be whatever we canceled out. So since it's x plus 1, it'll be negative 1. Remember, right? That's how we get the negative 1. Where do I get the second part of the point? This comes from what I canceled. How do I get the second part? I plug it right back into this problem, my new problem. So I'll have negative 1 minus 6, negative 1 minus 4, and negative 1 minus 1. So I'm just putting in a negative 1 for all of the x's. What's negative 1 minus 6? Negative 7. Use a calculator if you need to. What's negative 1 minus 4? Negative 5. And negative 1 minus 1. So negative 7 over 10. So negative 1, negative 7 tenths is my whole. So go left 1 and down 7 tenths, and put a little open circle. Now what about asymptotes? Now look at the problem here. After you canceled Do you still have a cannot be?
Yep.
You actually have
2.
two. You have a cannot be at 4, and it cannot be at 1. Wow. That's big time math. Who has a question about that? That's all one problem. This is the part you wrote down, but it took us all that to get there. Anybody have a question about that? Your heads are spinning. Well, they're gonna spin some more, cause now we're gonna throw vertical, or excuse me, horizontal asymptotes in. Okay? Come on now, stay with me. I only get to see you 3 days out of 4, so we have to make the most of every moment. All right, here we go. Old news is the vertical asymptotes. Now, let's make sure I haven't confused you totally. Is this problem gonna have any holes?
No.
No. How do I know?
There's no.
Legs.
There's
Won't
no
cancel.
canceling, right? How do holes happen? You have x plus 1 over x plus 1. You have factored and canceled. There is no factoring and canceling in this problem. So there will be no holes. Is there a vertical asymptote? Is there a cannot be value? Where is it? From the denominator. And if you said the denominator cannot be 0, then your cannot be is -3. X equals -3. All right, so that's the vertical. Done. That's old news. Now we're going to throw the horizontal in. Horizontal is a little bit trickier. Most problems are easy, but it can get a little bit trickier. To find the horizontal asymptote, I want you to take your pencil and I want you to put a box around just the x's. The horizontal asymptote will be at that ratio. In other words, 2x over 1x is 2 over 1. So your horizontal asymptote is going to be at y equals 2. Now, there's some math involved with that. It's the horizontal asymptote is a limit. That's what's called an end behavior asymptote. But we're not dealing with that. How we find it is we just put 2x over 1x. We don't pay any attention to the numbers when we do the horizontal asymptote. Just 2x over 1x. That seemed kind of easy. Let's look at the next one. Now, Olivia, can I factor this guy?
Yeah,
How's the top factor?
x minus 2x plus 2,
Beautiful. In either order.
and the bottom is x minus 3x plus.
Beautiful. In any order. Now, does anything cancel? What does that tell me about my picture? If nothing cancels, then I'm not going to have a hole. Are there any cannot be's though? There are 2. There's a cannot be at -3. Now I'm kind of doing that in my head. We've done a bunch of them. Are you okay with that? X plus 3 cannot be 0, so x cannot be -3. And x minus 3 cannot be 0, so x cannot be 3. To do your horizontal, go back to the original problem. And this time, we're not boxing in x's. This time, we're boxing in x squared. we box in whatever the biggest power of x is. So in this case, the biggest power of x is x squared, so I box those in. Now I have 1x squared over 1x squared. Where's that horizontal asymptote gonna be? At y equals 1. Very, very good. C on your own. I think this one's relatively easy. See if you can figure out where the vertical and horizontal asymptotes are for problem C. What do you think? Anybody have it figured out? Declan? So x cannot equal 4, so my vertical asymptote is at 4? X equals 4, is everybody okay with that?
Yep.
And where's my horizontal then?
1.
Yes, indeed, very, very good. Y equals 1, because 1x over 1x is 1. Perfect. All right, try D. We're going to get some fractions here. Do not be alarmed. Sandra, do you have any idea about either one, horizontal or vertical? Okay, would be where? It's going to be a fraction. Yep, it'll be a fraction. So to find it, we're going to say 8x plus 6 cannot be 0. So 8x cannot be negative 6. X cannot be negative 6/8, which I will reduce to negative 3/4. Is that okay? So that's my vertical at x equals negative 3/4. Did everybody follow along that? Okay, Jacob? Do you know where your horizontal is? It would be. It would be y equals 3/8. Because 3x over 8x is 3/8. Perfect. So just a couple more. I've thrown a lot at you today. We need a couple more and then we'll be done. Now you kind of got to get in the groove here, folks, of looking at your problem. So we're looking at E. Is there any factoring at all that we can do in this problem? The denominator. So if there's factoring to do, do it. Okay? So we're going to factor the denominator. Quinn, do you know how the bottom factors? It's the difference of squares. So it'll be,
X plus 2, X minus 2.
that's the old phone a friend over there, thank you, Jude.
That is you.
X plus 2, X minus 2, because that, Quinn, this is a 4. Square root of 4 is 2, that's how we got the 2's. Does anything cancel? No, which means that's fine, but it means there will be no hole. But there are, because of Quinn's factoring here, there are 2 cannot be's. So where will those vertical asymptotes be? At x equals -2 and x equals +2. Now, how do I find the horizontal asymptote again? I box it in. Who was listening when I told you what we box in? What do we box in?
The highest power.
The highest power. So I want you to look at the problem. What is the highest power in the problem?
X squared.
X squared. That's what has to get boxed in, guys. But wait, there's no x squared on top, so I literally write 0x squared. Because that's what has to get boxed in. X squared. And if you don't have one, you put it in there. So now my asymptote is going to be at 0 over 1. What's 0 over 1? 0. So your horizontal asymptote is at y equals 0. When we box in to find our horizontal asymptotes, we must box in the highest power in the whole problem. If you're missing one somewhere, top or bottom, you gotta put in a 0. You good with that? All right, one more. All right, let's tackle one more. Y equals 2x minus 1 over x squared plus 3x minus 4. Okay, get started, do the first step. What do you think we should do first? Xavier, what are you doing back there? What do you think we should do first? Oh my. Look at all of our problems. What have we done first every time? Here's Jude, he's helping out. Guys, tell him, what do we do first? Factor. We factor. So, Xavier, we look at our problem. I don't think we can factor the top, right? Because it's just 2x minus 1. But what about the bottom? Can we factor that one?
Yes.
It's not the difference of squares, so don't be thinking that. They have to multiply to -4 and add to 3.
Plus 4 minus 1.
So plus 4 minus 1. Does anything cancel? No. So there won't be any holes. Are there any cannot be's? 2 of them. One of them is where?
-4.
-4. Make sure you are labeling your asymptotes. The other one is at +1. And now we need our horizontal asymptote. So go back to the original problem before you factor it. It's easier to tell from the original. What's the highest power?
X squared.
X squared. I have 1 x squared on the bottom, but I have none on the top. So when I box them in, I have 0 over 1, which is 0. So my asymptote is at y equals 0. Z. Okay? Now, get your calculators out. We're gonna sketch this guy and see what he looks like. We haven't gotten a picture up here, but we're gonna look at the asymptotes anyway. So go back to your original problem. A little word of caution. When you type this in, and this is problem F, when you type it in, parentheses divided by parentheses, okay? That's the way we want to do that. So, y, go to y equals, remember, I gotta figure out what's in there. Go to y equals, anytime you want to graph something, you gotta put it in y equals, parentheses, 2x minus 1, close parentheses, divided by, parentheses, x squared, plus 3x, minus 4, close parentheses, graph. Now, I don't know how your window was set. I probably should have had you set that first. You might want to go to Zoom 6, and that'll give you a nice square screen. And depending on how old your calculator is, your picture's gonna be kind of funky. There's different pieces of it, yeah? So it looks like over here, I've got something that looks like this. Do you see something that looks like that over there? Yeah. And then in between, it looks like something that looks like this is in between. And then over here is this. So eventually we'll be able to draw that on our own, but that's what the picture looks like. Now, if you have a new calculator, I want to see what it looks like on a new one. Yeah, that's a beautiful picture. That's so much better than mine. Yeah, you have a little funky one like me. Yeah.
My sisters.
Yeah, and that's okay. That's all right. The old school calculators, where should we get? Did you graph it, honey? Come on, Flynn. I want you to be able to do it. All right, I want you to know how.
I think you have the same she has.
Yep.
Probably like, I'll only have one more year of math after this, so I have to retake Precal and
Yeah, but
college.
it's sort of like asking to the mark. And I was like thinking, my grandma was like, and then what is this?
Precal. I mean pre-algebra. Yeah. I was like, wait a minute. Are we taking this shit? Pre-algebra in 8th grade.
I know. I was like, you're looking at me, I'm taking yours.
I told you to Zoom 6. All right, guys, that's it for today.
No.
That's it. We did a little graphing.